Well, hello and welcome back to the radio room. Still working on the FT101E. I want to do a quick video, just kind of keep everybody up to date with where I'm at on it. Not quite ready to do a fire up on it yet to see if it's even going to work. Just basically looking stuff over, trying to see what I'm getting into as far as um, getting this radio back to operational condition. Done quite a bit of cleaning on it still. I've done the top pretty much in the last few videos. We'd already covered what I'd changed. I do got the boards back in. I have pulled the RF board or the HF board back out. I wanted to get into the VFO, and I'll get to that here in just a moment. I was checking some stuff on it. So the processor board's just kind of hanging out here out of the way, hopefully. As you can see in the inset there, this thing wants to stay. I do have the faceplate off the front of the radio. I needed to get in there and check some things. Specifically, I wanted to check the switch right here in the inset. Let me go to that being on the screen for you. This switch right here, you can just looks black in there. It's actually broke off. It's the meter switch. I needed to get to find out what was going on with that switch. First off, it broke off, and then it's really hard to switch between it. It's a three-way switch. It goes between, let me see if I remember. I gotta look at the up would be power out, collector current or current, plate current probably is in the middle, and ALC is down. Right now I've got it in the IC position. I've kind of been looking around to see if I can replace that switch. I'm not seeing a lot of replacements for it. There's one or two on eBay. They're going for a pretty good penny right now. Or if there's an aftermarket that I can put in that, and that's possible. I'm still searching for that. If nothing else, I may remove the switch, clean everything up really good, where the tiny little bit of a stub of the handle is still left, or the lever, and see if I can fashion something to put over the top of it, the super glue, so you can still have the lever action there, so you can switch between the different meters. I did also clean up the faceplate. Go ahead and switch views here a second. I have cleaned up the faceplate. This is the plastic part that goes around the VF or the dial and the meter, and of course that switch sticks out right there. And of course there's the knob to change whether you have internal or external VFOs. The faceplate is in fairly decent condition. Got in there and actually got a chance to clean it up pretty good. It does have a spot right there. It looks like maybe the pointer had hit it right there or something. But like I said before, this radio's been around today, and it's lived a life. So to me, little dings and scratches, as long as they're not too bad, aren't that much of a problem. It just shows that the radio's been used. And it's done something besides just sit on a shelf and not be used. I mean, it was used as a radio. I still got to clean up the ring around that goes around the front. Still got quite a bit of dirt in here. I got a couple other things I'm going to work on. Let's go ahead and talk about the VFO. I'd mentioned before, I think it was in the first video when we were just kind of looking over the radio and seeing what was going on with it, that the VFO seemed like had some rough spots, or spots that it was slipping. and it still does have that. I did remove the Jackson Brothers planetary, and it's still got a couple little rough spots in it. I'm not sure there's going to be much I can do about it. I did take it apart, which is not easy. You can see these little tabs that are bent over around it. You have to lift those up carefully, and then there's a ring and then a little washer spring or spring washer that's in there, and then there's basically two halves of the front plate, the main body of it here. If you look down in here, you can see that it's kind of got a bevel to it right in here. And then I'm not sure you can see it real well here, but right on the inside of that, let me find something to point with here. Right on the inside of here, I'm not sure y'all can see it. I might have to get some more light. Hopefully this doesn't wash out. You can see that there's a bevel in there. What's between that is those two bevels come together and they're pushed with that spring, that spring washer, to keep tension on them like this. And in between there's ball bearings that ride inside of there. The internal shaft, the only thing holding that in there is those ball bearings. So they ride on a little concave portion of this outer shaft, with the outside of the ball bearings running on the concave portion of the frame, let's call it. But they're running through holes. See if I can get this up here. You can probably just see those ball bearings in there. They're running through little holes in that. So basically, it's just a planetary reduction. As you turn this, the inside of the shaft is on the inside of the ball bearings. In this case, making them, if I'm turning it this way, it's making those ball bearings turn this way. Well, since they're up against the outside, they want to roll around that track, and they carry this with it. Like I said, it's still got some rough spots in it. I'm not sure if that's maybe just from spots where maybe it had sat a while. I did take a lot of the grease out. It was pretty nasty and definitely very, very sticky. Right now, it's just got basically some light oil in there to keep it from wearing, especially where the shaft goes through here. That's not going to be the long-term fix if we're going to have the radio running. I'll either have to get a better type of grease to put in here. I might have to do some more cleaning, perhaps. I might have to get in there by taking it apart and almost sort of polish the two tracks. They could have maybe some rusty spots in them where the ball bearing is kind of running up against it and it's almost acting like a wheel chock. But it does. I was worried that just putting oil back in this, it might not grip the ball bearings, the center shaft, grip the ball bearings enough, or the outer case to make them roll and drag the center part along with them. It seems like it's got fairly good torque. I'm holding the body of it and turning the shaft, and you can see it's trying to drag my thumb along with it every time I get to one of the set screws. And of course, this is the part that goes right here. It slides on the end of the VFO gear right there, and of course there's two screws that hold it in place. So basically, getting this out of here, I went ahead and removed the faceplate because I want to look at this switch, and I want to clean this up. I still have quite a bit of cleaning to do on the behind the faceplate. I want to make sure, get these switches clean all the way back. I still need to get in and maybe shoot some deoxit on them to clean them. They're all free. They're not sticky. So mechanically, I think they're sound. we just need to clean that up. Of course, right here is the bulb that goes about right here. It actually is in the back of this. It goes right there. It's what makes that little triangle light up right there. Or right below that. Yeah, there. I don't think you can see it in the camera, but there's that little slot right there. You can just barely kind of see through there. It shines down through there to illuminate this, so you can see where that marker is on the knob dial. I had to cut. I cut that mostly because this needed to come off, but let's see if I can find it. Wherever this was coming through, let me see if I can. Actually, it would have fit through there before, since I didn't have this cleaned. There was some reason why I couldn't get this. I was trying to avoid having to take this off completely, because the cover goes around this, and I wanted to at least get that piece off, but I couldn't get it out through that hole that's coming through right there. Anyhow, I cut the light off. I'll wire it back in. In fact, what I need to do is just take a VOM and see if this bulb's even any good. Now would be a good time to change it if it's not. So back to the VFO. I've already mentioned this port. I kind of got working a little bit better. It's still got a couple little hook, hang-ups in it. Right there's one. You probably can't tell. It's more by feel, and a lot of that might not be as noticeable with the knob on there. I'm just turning the shaft with very little, leverage here, and that might clean up a little bit. A little bit of use there might be some stuff I couldn't get cleaned off good on it. But the other problem is when I was turning the shaft in here, let me get down a little bit closer. When I was turning the shaft down in here, right in this area right here, there's several gears in there that come from that shaft and do some more reduction. And right about, it'd be about the 100 on the dial. Right about there, it gets really rough. And I'm not exactly sure. It's almost like the gears are not meshing very well. Maybe they're dirty. Maybe they've gotten boogered up a little bit. I also don't have a lot of force that I can turn this knob with right now, because I'm kind of reaching in the radio and can barely reach it. There's another spot right about 100 kcs from the top of the travel. That's probably going to involve removing the whole VFO so I can get to this gear system and check it out more. But it is working at the moment. As long as the Jackson Brothers drive has enough torque to take it past that, it'll work for right now. I did verify that this variable capacitor right here is turning fine. I basically just, sorry about that. I loosened the set screws here. First off, I had it completely seated, which also, by the way, does put it up against the stop that's in the, there's a little tang that sticks out so you can stop. So you're not using the capacitor to physically stop your movement. I unhooked these so that this could free spin. This is just a coupling that goes to the shaft, out through there that goes to this gear up here. I did undo this coupling, and turned the VFO with this being still, and it still had the same rough spot in it. So it's not here. It's got to be up here in the gear system. But right now it does get past it. It will work. But in the long run, that's something that's going to be addressed. Let me go ahead and pull the camera out here for us. Get a little bit of room to work with. So that is something that is going to be revisited. I want to make sure the radio is going to actually operate before I go too into depth into fixing some of the smaller stuff. I also did find, this is the shaft that goes over here. It's to the loading capacitors right back here. You know, so this was basically right there. That's where that knob was broke off on the front. I was looking on Amazon, and it appears I can find, this is about a 1/4 inch round. They make some clear acrylic shafts or rods. I think they're for doing flowers or something. They come, you know, they're 12 inches long. And I'll just have to cut one down, but I'm pretty sure that'll work real well right there to replace that. So I'll get that ordered. We'll probably fire this thing up before that even gets ordered or comes in. Our initial test on this, firing it up, we're not going to do any transmitting, so we don't need to set the load. On the bottom side, I did do some more cleaning on the bottom side. Kind of blew it out. I got to be really careful. I don't want to crush that processor board, so I got to set this down real gently. Try to. Did clean up the bottom a little bit. It, you know, had a little bit of dust. Fortunately, it's on the bottom. You know, gravity was kind of helping keep it clean a little bit. One other thing I'm going to do, because I'm still going with the plan that we're going to have this radio working in the long run. It might take a while, but we're going to get it done. Let me go ahead and move this cover off of here. I've already had this off once to clean in here. I just needed to put it back on because things were starting to get pretty spread out on the workbench here, and I did not want to start crushing parts, losing parts. So we'll get this off of here, and I'll show you a couple of things we're going to take a look at in the future before we're ready to transmit on this. In fact, I might check some of this stuff before we even fire it up. When I fire it up the first time, I'm not going to have the tubes in it. We're just going to basically do a receive test. And the reason for that is that, well, there's one capacitor in here that if it's bad, I do not want to turn the radio on, even in receive, if it's bad. So this is kind of the PA section right over in here. This is the two tube sockets for the final tubes. The driver tube you'll look at underneath there. But what I have got to check, and what I'm probably going to do is not in, I'll probably check it just for curiosity's sake. But what I'll probably end up doing is replacing this capacitor instead of just checking it. Even if it checked good, I still want to make sure that it's reliable. And this thing has been in here since the radio was built. And I'll show you something here real quick. Let me see if you guys can see down in there. Let me kind of move down there a little bit closer. And I might have to put a little more light on it. But first off, them two red things you're seeing there are resistors. There's a resistor here, a resistor here. There's, I believe that's a resistor right back in here. And these are, you know, not quarter watt, half watt resistors. I think one of these is like a 3 or 4, maybe higher wattage resistor. So it's dissipating a lot of heat right in here. Well, with this trimmer board right here and this cover over here, this is like a little oven right here. And if y'all can recall, heat and capacitors don't necessarily get along. They don't like to be hot. They don't last as long. Let me see if I can get to see that. Okay, you can. Right back in here, this guy right here, this is C13. It's an 80 picofarad, 1000 volt capacitor. It runs from the output of the driver tube over to the final tubes. It basically is blocking DC from best I can see. It's just kind of a blocking capacitor. So if it shorts out, you're going to have a lot of voltage going across here, straight into the final section, which is probably not going to make the final tubes very happy. Let's see if we can find this one on the schematic. I do have my schematic now all nice and taped together, and I'm hoping y'all will be able to see this. This is C13. Is the one we're looking at here, which is right here. Let me see if I can get this in a spot y'all can read it a little bit better. Hopefully it's going to focus once it stops moving. I'm not sure y'all can really see that. I might be a little bit too close. Anyhow, right side here is C13 right here. So if we follow up this way, we're going towards the driver tube. That's right on the plate of the driver, the 12BY7A. So that could have plate voltage on it. And that runs over to the grids, it looks like. Yep, the grids, control grid, I think maybe. To our two final tubes. So you don't want that voltage going to there, the DC voltage. You just want the AC of the signal coming there to be amplified. So that's going to block it right there. If that shorts out, and from what I understand, if they fail, they short. It's going to be coming right off the plate voltage from that driver tube. It's going to be coming right over here and going to make things really hot and really unhappy. Probably burn the tubes out, I would assume. So that's definitely something I'm going to change before we try to put the tubes back in. I'll probably, it's kind of crowded down in there. I'll get that one out and change it. I'll probably check the values of these two resistors since they have been in that oven basically right there. Let me go ahead and get this back in here. This is a little bit more of a trick than it looks like. Move y'all out a little bit. So I can get some room. I also, right here, you can see this bonding strap. It was just about to break off. Basically what I did is cleaned it up real good, put a little flux on there, and soldered it back together, so it should stay put now. Let me go ahead and get this plate back on here. Move this up a little bit. Get everything lined up good. We'll get all these screws back in here real quick. So while I'm putting this back on, I did get a chance the other day to, I think it was a week ago now, to speak with the previous owner of this radio and got a little bit more information. He had purchased it. I want to say it was back in the 80s. I want to say probably I think he said somewhere around like 87, 86. He obtained this radio, and I believe he said it might have been one of his first HF radios, and used it quite a bit. He has changed the final tubes in it in the time that he had it, and really enjoyed running the radio. He did end up having to put the radio as basically just got stored for a number of years. And when he brought it back out of storage, now the radio was working when he put it on the shelf, so to speak. It was working good. Didn't seem to have any problems. After sitting a while, he did get it back out, hooked it up, and found out that he had no audio. I do not recall during the conversation we were talking about several other things. If he mentioned that it just wasn't receiving, or if it's just flat had no audio. I am kind of suspecting there's probably no audio. If you remember, when we were taking a look at the boards, I was showing the audio frequency board. Let me show you which one that one is again. Which is this board right here. And if you remember, that's the one I was pointing out that it had a bunch of cracked mica or mylar. Let me actually get it right this time. The last video when I was talking about it, I called them mica. Mylar capacitors. Maybe that's where the problem is. Maybe this board is having some problems and needs to be recapped. Or perhaps, and it could be because of the capacitors, the audio amplifier chip might have went bad. We're going to have to do some testing on it. When I do this testing on that one, and this might take me a little bit to get done, from basically just being able to work on this stuff a little bit on the weekends. I'm going to build a signal tracer. I've found a couple of plans online, a couple of different viewpoints, a couple of different approaches to a signal tracer. I think I do want to kind of go with an active one, just so I can get a little more amplification out of it. But I want to build a signal tracer. I don't have the extender boards to work on an FT101. Extender boards, if you remember, these boards just slide into strips, mounts down there. Like computer cards slide in. So normally when you're working on these, and you do it very much to make it worth the cost of having the extender boards or building them, which in itself still takes some cost, is you pull the board out and it's just a long board. Let me use this as an example. So you'd have the board. You have a piece of board, just circuit board, with strips, traces on it. And each one of those strip traces lines up with the pins. Let me show you almost like this. So here's the HF board. It's got all these strips right here that slide into those connectors. Basically, when an extender board just has this on one end, like that, and on the other end it has another socket that the board can slide into. So the point being, you can slide the extender board down in there into the socket and slide the board on top. So now the board is up above where you can probe at it, take a look at things, whatnot, without it being down in there. Because right now, there's really no way for me to probe anything. So what I'm probably going to have to do when we get to that point, if we need to start probing things on these boards, is what I'm going to have to do is I'm going to have to decide, okay, what do I need to probe on this board? Is it an output of the audio amplifier? Do I want to, I'm probably going to want to probe where the audio is coming from the volume knob into this board, which is going to be all the way down on the connector. There's no way to get down in there. What I'll do is I'll decide everything I probably want to test on that, and I'll solder tack wires to those points. So I can bring them up here, probably put some tape or something on them to label them, and kind of keep them, in a safe place. We don't want them coming up here and just laying, because I'll have to have the ends of the wires kind of stripped back so I can put my probe on them. But probably maybe tape them all together with a piece of plastic underneath them or something, just kind of laying up here. That way I can probe those certain points with the board in there in operating position with the radio on. Otherwise it's going to be a little hard to check a lot of this stuff. And it might just come down, it's got to be recapped. But we'll check to make sure that there's audio coming to the board. That's going to be a good start. And we can trace through the board and find out where it stops. That's what's great about a signal tracer. That's on audio frequencies. You come down here and I can probe where the audio is coming to the board, and it's going to be a very, very low level. Well, there's an amplifier in the signal tracer, so I can take that, probe it, and we'll hear the tone or whatever we happen to inject into the radio in the signal tracer's amplified speaker. And then, okay, well, if it's getting to the input, well, let's find out where it's stopping on the board. It might be running all the way to the board and it's not coming out the final amplifier, which basically goes nearly straight to the speaker after it comes out of the amplifier. So if it's coming, we can check the input to the amplifier. If it's going to there, but it's not coming out the amplifier, more than likely, we got a bad amplifier. So we can definitely check that. I gotta build a signal tracer. kind of something I've wanted to do for quite a while, and this has really given me a reason to. Just got to get the parts together, decide which plan I want to use, which circuit I want to use, and get it built. But in the meantime, we're going to continue doing some more cleaning on the faceplate up here, get all the switches cleaned up, and hopefully in the very near future, we're just going to do a fire up test to make sure that this thing turns on. Probably try to check some voltages coming out of the rectifier board, make sure they're pretty close to where they need to be. And of course, we're going to do all this on a dim bulb tester so we can current limit. If there's any shorts in this radio, particularly on the rectifier board, say a capacitor, it's going to limit the current that this radio can draw on the power, because we don't want to start taking out transformers. That's where it gets really expensive. So that's where we're at. I'm trying to think if there's anything else I want to bring up. Well, one thing, the goal, of course, is to get this radio working again. And I really want to, when I finally do get it done, get it tested, try to do as much alignment on it as possible. I'm going to contact the previous owner, and we're going to set a schedule, a sched contact up, and I kind of want to make the first contact that this radio does with its previous owner. I already talked to him about that. He thought that was a really cool old idea. So I'm gonna video that when we do make that contact, and he can hear this radio back on the air again. So that's where we're at. Hopefully in the very near future we'll just have a video where we're going to turn it on, see if it does anything, see if it receives anything, maybe put a little signal into it, and just see what's going on. We might be able to do some testing even without a signal tracer to find out if the audio is not coming out of it, where it's stopping at. But I want to build a signal tracer anyhow. Even if I figure out what's wrong with this radio without it, I still want one. They can come in so handy instead of trying to figure out how to decide where things are going. You can use an oscilloscope and compare. Okay, what do I got coming out of there now? You can do that, but you're probing, you're looking, you're interpreting what the oscilloscope's telling you. A signal tracer, it's you touch it, and if we got a say 1,000 hertz tone coming in here on our injected signal, as soon as you touch it, if it's there, you're just going to hear it. So you can go beep, beep, beep. Oh, we don't have anything here. So it's somewhere between those 2 points is where your signal's being lost. So thanks for stopping by. We're going to continue this journey and see if this old FT101 is going to come back to life. Still got a little bit of work to do on it, but thanks for stopping by the radio room. Bye for now.